नमस्कार दोस्तों, स्वागत है आप सबका हमारे चैनल पे, जहाँ पे हम बात करेंगे एवरीथिंग रिलेटेड टू जियोलॉजी। कॉम्पिटिटिव एग्जाम्स में कौन कौन से क्वेश्चन मोस्टली पूछे जाते हैं, सब आजकल डिस्कस धीरे धीरे होगा, तो जुड़ जाइए इधर पे। तो आज का टॉपिक बहुत ही इंटरेस्टिंग है, स्टीरियोनेट रिलेटेड प्रॉब्लम्स है। तो स्टीरियोनेट में एक टॉपिक आता है जो कि है बीटा डायग्राम एंड पाई डायग्राम। तो आज हम लोग बीटा डायग्राम और पाई डायग्राम के बारे में सीखेंगे। अगर आप लोगों ने इसके बारे में कभी पहले सुना है तो कमेंट बॉक्स में लिख दीजिएगा। ओके, तो बीटा डायग्राम सबसे पहले स्टीरियोनेट का, इसको स्टार्ट करने से पहले स्टीरियोनेट का आपको बेसिक्स पता होना चाहिए। मैं यहाँ पे बेसिक नहीं कवर कर रही हूँ। अगर आपको बेसिक इसके बारे में जानना है तो आप कमेंट बॉक्स में लिख दीजिए, मैं उसको भी कवर कर लूँगी। ये डायग्राम उसके लिए है, मास्टर्स के बच्चों के लिए मोस्टली, जिसका स्टीरियोनेट का कॉन्सेप्ट क्लियर है और वो बस बीटा डायग्राम के बारे में और पाई डायग्राम के बारे में जानना चाहते हैं। तो बीटा डायग्राम क्या होता है? सपोज ये ले लो, हमने एक स्टीरियोनेट लिया है। स्टीरियोनेट में ये एक प्लेन है और ये एक प्लेन है। ठीक है, ठीक है, ये मैंने दो प्लेन ले लिया है। और चलो 3D में एक बार मैं फोल्ड एक बना देती हूँ। ये एक फोल्ड है, 3D फोल्ड है, स्ट्रक्चरल फोल्ड है, स्ट्रक्चरल जियोलॉजी का फोल्ड है। ऑलराइट, तो यहाँ पे ये क्या है, इन्फ्लेक्शन पॉइंट मैंने बना दिए, ये इंटरलिम्ब एंगल बना दिए। ठीक है, तो ये क्या है, ये एक लिम्ब है, ये दूसरा एक लिम्ब है ना? कुछ ज्यादा ही ऊपर हो गया ये। तो ये एक लिम्ब है और ये एक लिम्ब है। तो हम ग्रेट सर्कल में जो आप ये दो प्लेन दिखाई दे रहे हैं, ये प्लेन क्या है, ये लिम्ब्स है, दो लिम्ब्स है, लिम्ब ऑफ फोल्ड्स। ऑलराइट, limbs of folds, and these limbs, where do they intersect? They intersect at hinge point, right? So they hinge point, so this is our hinge point, because these are the two limbs of the plane which we have represented using great circle. These two planes or limbs, they are intersecting at a point. So this point is the hinge point. Alright. So just, it is very simple. It is very simple. Okay. So beta diagram is what? From the poles, what we represent? An intersection point. Intersection point. From poles, from sorry, from planes we represent what? An intersection point. This intersection point is what? A pole. All right, a pole, plane to pole. From plane we are representing an intersection point, pole. So this is called as beta diagram. So how many intersection point are there in this diagram? We have one beta. And how many planes are there? We have two planes. All right, one more example we will take. Let me change the pointer color. One more stereonet, but in this case we see that there are lots of plane, and they are intersecting at several points. 1 2 3 4 5. We have five betas. And how many planes are there? 1 2 3 4 5, around 5. 1 2 3 4 5. We have 5 planes here. 5 planes, right? We have 5 betas and 5 planes. But why in this case we see that there are so many intersection points, but in this case we see that there is only one intersection point? So the in the stereo net, if we get only one one intersection point we get, then that type of representation is for what? Cylindrical fold. Okay, that type of beta diagram representation is for cylindrical fold. All right, but in this case we see that there are lots of intersection points. So if there are lots of intersection points made by the planes, that type of stereonet representation is for non-cylindrical fold. All right, this is non-cylindrical fold. but in nature we mostly get non-cylindrical fold. For theoretical representation, cylindrical is suitable, but if we go to the field, then mostly we encounter non-cylindrical folds. Alright, so that much only. Then okay, this is the representation. This is quite a good diagram. I was drawing roughly, so this is the good nice one. So see, there are two planes, they're intersecting at a point. This point is what? This point, intersection point. We plot here as from planes to the pole. This intersection point is the pole. Again, there are so many. If what I said, if there are so many planes making an intersection point, then that one is for what? Non-cylindrical fold. This one is also for non-cylindrical fold, and this one also. So that's all. This is the beta diagram. Now let's come to what? S-pole gridle. You see the diagram here. S-pole, S-pole, or what? Pi pole, we can say. Its name is pi pole also. Pi gridle, S-pole gridle, pi gridle, or great circle gridle. Great circle gridle. So in this case, what we do? Now we have so many poles here, so many poles here, so many poles here. So these poles, they are tangential to the fold surface. That means these poles are the vice versa of what we did in beta diagram. These poles represent intersection. That means these poles intersect at some point. They are tangential to the fold axis. Right? Tangential to the fold surface is what? They are intersecting and at some point is called tangential to the fold surface. Now these two are the poles. From these poles we can make a great circle, right? We can make a great circle, and this great circle represents what? Hinge line, hinge line, or fold axis, or axial trace, or fold axis, or axial trace. Alright, from so in this case what we do, we make representation from poles to plane, right? From poles to plane. We are just following where the poles are directing towards. From these poles we are making a plane. Alright, and this plane, what does it represent? It represents a hinge line or fold axis or axial trace. Alright, see this thing, it is representing this thing. Okay, so what is this called? S-pole griddle, pi griddle, or great circle griddle. This is very easy. One more example, in GATE exams they would ask that, they would give us some points. Alright, they will give us some points and they will ask us whether it is a cylindrical fold or non-cylindrical fold. If they are haphazardly here and there, then we will call it as a cylindrical fold. We will call it as a non-cylindrical fold. But if they are having some kind of orientation, say for example, if they are haphazardly, they are in so many places, here, then this is what? Non-cylindrical fold. Okay, but if they are making some kind of orientation, then we will call it as a cylindrical fold. That's it. This was such an easy topic. It just seems like it is difficult, but it is not. I hope you understood. Thanks for today. Bye bye.